Hello, everyone. Welcome to this presentation where we want to look at partial differential equations. Okay. In this case, we want to see how we can classify a PDE as either being elliptic, parabolic, or hyperbolic. All right. Okay. So we are going to check the conditions for a PD to be elliptic, parabolic, hyperbolic. What conditions do we need to satisfy? All right? Or what is it that we must look for in order for a PD to be elliptic? Okay. Parabolic as well as hyperbolic. Okay. And let's look at this question. So we are saying classify the Poisson equation, this one. So we need to classify this. Either it is an elliptic, parabolic, or hyperbolic. Okay. Now to do that, we need to use D, all right, which is B squared minus 4AC. Now, number one, if D is less than 0, then the equation is elliptic, right? If D is equal to 0, then the equation is parabolic, all right? It is parabolic. Okay. Parabolic. The equation is parabolic. Then the last condition that we need to know is if D is greater than 0, then the equation is classified as hyperbolic. Okay. It is hyperbolic. Now, to do this, we need you need to know the general form. Okay. Which will help us determine the A, B, and the C. And what is our general form? That is A U subscript XX plus, so A, it is the coefficient of this second derivative. Okay. Then plus B U of XY, okay, plus C U of YY plus D U subscript X, okay, plus E U subscript Y plus F of U plus G is equal to 0, where U is a known function. Okay. So we are saying A is a coefficient. Okay, so we're saying A, it is the coefficient of the second derivative regard to X. B, it is the mixed derivative the coefficient of the mixed derivative. Then C, it is the coefficient of the second derivative with regard to y. Now, what is our equation? Our equation is given as, I think, alpha, open bracket, partial squared u divided by the partial derivative with regard to x squared, plus the second partial derivative of u with regard to the partial derivative of y squared, and that everything is negative f. This is our Poisson equation, all right? So now, what we can do is, you can multiply both sides. You can multiply both sides by 1 over alpha. So we have the second derivative of u with regard to, that is partial, that is to x, plus the second partial derivative of u with regard to the partial derivative of y. This is equal to negative f divided by alpha. Okay. Now, if you compare with our general equation, you discover that here, where we have the second derivative of u with regard to x, which is this one, is our a. That is the coefficient here, all right? That is the coefficient here. Here, that is the coefficient here. And so our a is 1. Then we don't have the mixed derivative, so meaning that our b is 0. Then in this part, the coefficient of the second partial derivative with regard to y, okay, the coefficient here is 1. Okay. So now, what does it mean? We can get our discriminant. What is our b? So we have 0 squared minus 4. What is our a? Our a is 1. Then our c is 1. Okay. So what does it mean? Our discriminant is equal to negative 4, which is less than 0. So when the discriminant is less than 0, therefore, the Poisson equation is an elliptic PDE, partial differential equation. And that's it. That's what you need. Just you need to use your discriminant provided you know the general form. Okay, please subscribe to our channels. Mbanpiri JM. Chaomba Mbondo. Okay. Till next time, watch out for some more videos on partial differential equations. Bye-bye and God bless.